Okay, chaps, I'm going to record a video looking at the end of year exam for year 10. Now, the reason I'm doing this is because I took Miss Rutter's class today and I will take my classes later on in the week. And I know a lot of you are away on D of E, so only half, 3/4 of you are going to get feedback. So I thought what I'd do instead is produce a video giving some feedback on the marking, on how we marked the paper, on the mark scheme. And then you can mark your own, or not necessarily mark your own, sorry, you can look at your own and see where you lost the marks and how you can improve and what you need to learn in future. Okay, so let's kick off just by having a quick look at the paper. It's out of, I think, 76, not 75 marks. And we start off with 8, I think it is, a couple of blanked out, multiple choice questions. As we can see, a couple of them are removed, and then we've got 1, 2, 3, 4, 5, 6. I think 7 and 8 are blanked, and then we've got 9 and 10. So if we go to the mark scheme here, the first 10 are, let us just pull them down. Let me just pull them down. There we go. So we've got biomass, and we've got shortened lifespan to do with obsolescence, to switch equipment on and off, photochromic pigment is a smart material, woven fabric. Some of you put knitted in there. Knitted is when you make knots. Woven is a sort of under over lattice. Okay. Due to an improvement in material, I think that was to do with a composite. Was that right? Let me just. Technology push. Sorry, describes when products are developed due to improvements in new material. And then we've got a couple at the end. We've got a pulley, which is that image, and we've got something is ductile if it can be drawn into a long length. So that's the first 8 questions, and then we go on to question 11. Here we go, so 12 actually. Composite materials such as foil and polymer lined boards are used in food and drinks packaging. Give one advantage and one disadvantage of using composite materials for packaging. Well, why do they use composites? It's usually to alter the properties. That may make it more rigid, make it stronger, more durable. Often, and we're looking at a drinks bottle, if that was made out of paper, would it work? Probably not. The water would soak into the paper inside. So they put something like a plastic or an aluminium foil inside, so it makes it waterproof. So that's one of the marks there. So it can make the material waterproof. A disadvantage, if you've got 2 materials joined together by a glue, of course it's harder to recycle. And so its recyclability goes down, for example. Let's just have a quick look at the mark scheme and see what they say. Composite materials such as foil and polymer. Okay, the advantages: improve resistance to water absorption, improve insulation properties. Good one, isn't it? Improve ability to preserve contents, improve strength and stability. Disadvantages: recyclability. It doesn't degrade if littered. Same sort of thing, isn't it? Difficult to separate. Again, the same sort of thing. So we're going to go to the next question, which is Table 1 shows the number of food and drinks containers successfully recycled by manufacturer in 2010 and 2017. What is the percentage increase in recycling of composite food and drinks containers? Okay, so we know what we're doing is we're dividing one by the other to get a percentage. And so if we have a look at this, what have we got? We've got 14 divided by 32 times 100 equals 43%. It's a percentage increase, isn't it? Sorry. So 14 being the amount you have to add to 32 to get 46. Okay, so it's the increase of 14 billion tons. Okay, we're dividing by 32 to give the percentage increase. All right, just have a look at that again. 14 divided by 32 times 100 equals 43.7. All right. And the next one is a systems question. Let's have a look at that. Input block, process block, and output block. Now, some of you are going to find this, I suppose people who are doing RM, a little bit more tricky. Sorry, it's very hot. Just having a drink. The input block is things which are being affected by the external environment. Now, that all sounds very technical, but what it means is switches, for example. Someone pushes a switch. It could even be an LDR. You know, the light comes on, and therefore an LDR, light dependent resistor, senses a change in state, and therefore processes a signal to what's called the processing block. All right, and so it could be a microphone even reacting to sound with the input. Process block, it's sort of like the computer, the microcontroller as we call it. So that can be an Arduino, that could be a Genie, that could be a PIC, that could be a transistor, and that would receive a signal, and with that signal it will do something. It will allow an output to alter the external environment. Now, it will alter the external environment by maybe heating up, so it increases temperature. It may sound, so for example, it may be a speaker that makes a noise, and so the external environment would increase in volume. And so that's what we're looking for outputs. Now, that's all very technical, but basically what we're talking about is inputs are switches, processes are transistors or microcontrollers, and then outputs are speakers, heating elements, for example, all sorts of lights, LEDs, so anything which affects the external environment. There's loads and loads of them, and let's just have a quick look at all the different ones you can have. Bell, LED, siren, as you can see are the suitable outputs. The inputs, light sensors, pressure sensors, switches, pads, motion sensors. This SPST is a single pole, single throw. So that's like it's a bit like a rocker switch, one that's just on and it stays on, and then you switch it the other way and it goes off and it stays off, like an on and off switch on sort of an old-fashioned item, maybe an electric game or something. And in the middle here we've got the PICs, we've got the Genies, PIC-X, Arduinos, Crumbles you're probably not aware of, Genies, transistors in there, microprocessor, transistors in there again, time delay, monostable, astable. Okay, so let's go on to the next question. And already we are finishing section A, and we're going on to section B, which is specialist technical principles. Answer all questions in this section, all the ones that haven't been removed, I suppose. Name one specific commercial manufacturing process and describe what it is used for. Right, there's a little bit of confusion here about what exactly is a manufacturing process. Now, I've had a conversation with different people about this, and manufacturing is sort of adding, taking away, altering the form, altering the shape. For example, vac forming. You've got a piece of sheet plastic and you suck it over a mold and you alter the shape. For example, injection molding, where you're injecting molten plastic into a mold, waiting for it to cool, and then out comes, you know, a little toy figure or something. What it isn't is really surface finishing. Surface finishing is more like painting, varnishing, galvanizing. And so I had a couple of people put name of the process galvanizing, and I had a big conversation actually with Mr. Towers. Is galvanizing a manufacturing process? And we decided that really no, it wasn't. It's not in the mark scheme, and it's much more of a surface finish. But I think it's a little bit of a grey area, this. And so, yeah, some of you got this sort of wrong, but nearly right. And a lot of you got it right. And some of you got it absolutely wrong. Putting things like design specification. That is not a commercial manufacturing process. So to draw pictures, I mean, that I can't verbally describe, but what I can do is just look at the answers we've got here. Of course, within your different disciplines, you have different manufacturing processes. I'm going to probably leave papers and boards, just look at timber base. We've got routing, turning, lamination, machine mortising, and then we get to the metals. We've got milling, casting, welding, brazing, sintering, and we've got the polymers, injection molding, extrusion, vac forming, calendaring, rational molding, blow molding. Blow molding is a great one to learn. Vac forming is a great one to learn, really simple as well. Injection molding often comes up, it's a really good one to learn. Sintering never comes up, brazing never comes up, welding very rarely. Casting does come up, but casting is also, it's got a lot of similarities to things like injection molding, so it's really good to sort of understand that process. All right, I'm going off topic. Textiles, I'm not going to do. Electrical and mechanical systems. I would probably, if you're one of the electronics guys, wave soldering is quite good. Flow soldering is quite good. Pick and place technology is quite good. PCB lacquering, I wouldn't, and PCB manufacturing etching, you should know about this. But yeah, I would generally just go for this vac forming and injection molding. I think they're the best. So you've got to do a decent picture, explain the process, and also include some of these points. So hopefully you can have a look at those and just see where you fell down on marks if you did. Let's go over to the next one's a remove question, and then we have 5 different products, and we have can opener made out of stainless steel. We've got the shoebox made out of corrugated card. We've got this, is it a taupe bag, sort of woven bag? I think it is anyway. I think it's a woven, yeah, it's textile, so it would be. Now we've got a wooden toy, and then we've got polymer gears. So polymer gears would be very durable. That would be made out of something like nylon. Wooden toy, that would be made out of beech. I would have thought maybe a softwood pine, making sure it's quite light. Can opener stainless steel and corrugated cardboard. So when the specific main material for the wooden toy would, for example, be pine, would be beech. Some of you put oak, and I'm absolutely fine with that. All right, but the stock form used in manufacture, that means what are you, what would you ask for when buying that particular timber? For example, if it was made out of MDF, which is a manufactured board, you would ask for a sheet of MDF or a board, a manufactured board. If it was nylon, for example, which is a polymer gear, if it's a polymer gear which is nylon, this would probably come in beads of nylon. It could well come in rod, which you cut up and use. And stainless steel, for example, would come in rod. It could come in bar, for example, but that's what we're looking for. Wood generally comes, if it's a softwood, or if it isn't a manufactured or soft or hardwood, it will come in planks. So they're the answers. And appropriate finishing techniques: nylon self-finishing. With the wooden toy, we have lacquering, painting I accepted. Varnishing is another one you could have done. And stainless steel, self-finishing, we could dip coat it, we could put it in plastic, we could polish it. And with the card shoebox, well, it's printed, isn't it? And I don't know the correct terminology for that. So we will look to the mark scheme. And was I already here? I think that one. Let me just pop back and have a look at the 16.1. 16.1. Okay. Stainless steel, bar, strip, sheet. So you can put plastic over the top. You can leave it self-finishing. You can polish it. You could powder coat it. You can't galvanize it. That's not an appropriate finish. Shoebox. You got this lithography printing. We're going to leave that textile. beech, pine, MDF, plywood, I accepted oak, plank or board. A bit of an odd term, plank. You don't really ask for things in planks, but that's what you're taught. And then you can finish it in a cellulose, lacquer, varnish or an oil. Paint I accepted, as I said. Polymer gears, nylon, thermoplastic, polyester, long fibers, granules, pigment may be added, self-finishing again. So I hope that helps you. It's not the easiest of questions to understand what they mean, and I think that's been a reoccurring problem for my boys in this exam. A number of calendars are being made given the sizes provided in figure 5 and 6. How many calendar pages can be made from one sheet? I think it was 16. And then we had to, what percentage of material is waste after cutting the pages? So I think you've got to work out how much material is left and then divide it by the total. Let's have a look. Correct calculation here. 16 pages, yeah. And how do you do that? You just work out it's 4 sheets by 4 sheets. So that's just a little bit of trial and error of just having a look at it and just sort of working out. Right, moving on to the next part. We're looking at the waste here, aren't we? And then we're dividing the waste by the total and timesing it by 100. I always forget that bit because I just do it automatically. But we times by the total to give ourselves 5.76%. There's some alternative methods of doing it here, which you may have done. Each one is fine. Okay, which brings us on to the next question, which is responsible design. You should consider social issues in design and manufacture of products, analyse and evaluate how pollution caused by manufacture, use and disposal of products can impact the environment. So you've just got to make sure that you highlight exactly what you're meant to do, and you've got analyse and evaluate. So there's got to be not just analysis in this. At the end, we've got to sort of summarize and evaluate what have we concluded, how pollution caused by the manufacture, use and disposal of products are okay. So we've got 3 different areas here, and it's going to how does it all impact the environment? Okay, there's many different answers in this, so I'm going to go straight to the marking criteria, and it's a little bit difficult, and I imagine some teachers have marked slightly differently from others, but you can see here a fully detailed analysis and evaluation, and it's that bit there and evaluation. Lots of people analyze, but very few people actually evaluate of oceanic and or atmospheric pollution and the impact it can have on the environment. Several. How many? Several. Several's not 2. Several is at the minimum 3. Good examples for the response. So you can see if you want to be getting 8, you've got to make sure that you're evaluating, which I think everyone in my groups failed to do. A good analysis of both oceanic and or atmospheric pollution. Some evaluative points given. Sorry, I'm at home and that's my dog. So you can see as we go down the mark scheme that we have to provide less and less information as you would expect. We've got indicative content, and then we've got about oceanic, oil, microbeads. Lots of people talked about microbeads and plastics. Pollution in seas, atmospheric, acid rain. A lot of people talked about carbon dioxide, carbon monoxide, particulates weren't really touched on. Okay, I think that we did that personally, that question quite badly, and I wasn't really awarding very many marks for that. All right, so let's go to the next question. We've got on page 14, that question is removed, and so now we're on section C, designing making principles. Answer all the questions in this section, of course only the ones which haven't been removed. So we have 8 different companies, and this is going to be the sort of thing that you're going to get in your final exam. So you need to know and you need to decide on which companies you're going to specialize in. And the massive problem that we have had, we haven't really done this, and we have done it a little bit, and we had a page in our previous project, I'm talking about my boys, looking at specific designers. But to be quite frank with you, we're not looking at them in enough detail. What I would suggest you do is you walk away with 2 or maybe even 3 designers. The ones that I would probably go for are Alessi and Dyson. And I would do that because they use very similar manufacturing techniques. Dyson is all about colour and injection moulding. Alessi is about casting of metal, it's about injection moulding of plastic, and it's about funky kitchenware. That's the 2 which I like the best. But no matter which one you like and which one you choose, you've got to know what products they produce. I think it was 2 kids. Francis, I think, was one of the kids in my groups, and he could actually name a product, the Juicy Salif. And if you can't name a product, then you're going to be falling on your face right from word go. Naming the iPhone isn't enough. You've got to talk about why the Juicy Salif was sort of groundbreaking in what it was doing, and why it was completely representative of the Alessi brand. Or the DC-1 Cyclone was completely revolutionary, where hoovers were concerned or vacuum cleaners were concerned, because it had a see-through compartment. You could see the dirt it was picking up, and it had this Cyclone technology. And I think a Dyson's got something like 1,000 patents in it. So you've got to know about what are the specific products that company produces. Okay. And it says it down here: outline the design features and or manufacturing techniques that have made your chosen company successful. You should refer to specific products. So that's more than one in your answer. So if you're hoping for that 6, you've got to swat up on, I would have thought, at least 2 of these, and make sure that you're familiar. I'm not going to go through all that. I'm going to jump to the mark scheme, but all of you would have done different things. So it's not this one, is it? That's like batch production. Thorough description of a wide range of design features and or manufacturing techniques provided for one company. 2 or more clear examples provided to support. Okay. So if you want the top marks, and that's the top 30% of that, isn't it? You've got to start knowing specific products. Let's just have a look down. Whistling bird kettle, similar to what we saw earlier on, actually. Juicy Salif and a G corkscrew. I don't know what that is. Condiment set. Apple, maybe you could go for the apple, though, if you're really into that sort of stuff. Bronze, pretty cool as well. Dita Rams, that's a nice one to look at. And that, interestingly, doesn't talk about specific examples. That talks about general features: unobtrusive, honest, long-lasting, aesthetics, innovative, environmentally friendly. So it's got one here, sorry, Braun. 6th rare, I've got no idea what that is. Okay, what I like about this is it's great. DC O1 first dual cyclone. They're really simple facts to learn. Okay, so I'd go to town with Dyson personally. That's because I quite like Dyson. I'll scan through just in case you've chosen any of these other ones, and you can just stop this at a convenient point. Okay, 3 kettles. So let's go back to the questions and have a look at them. We did okay. What's that awful word it's got in there again? Analyze and evaluate. We've had a lot of analysis, but was there evaluation? We've got 3 different sections here, and we've got 12 points in total available. What I think it wants discussion in regards to each one of these headings: ergonomics, function, and whatever the other one was, innovation, I think. And then it wants a little evaluation at the end to say, in regards to ergonomics, I feel the polymer electric kettle was by far the best because of the points I've made previous. But very few people sort of summarized at the end what they wanted, what they were doing. Okay, we can see this is going to be a heavy old kettle, made of one material, so easily recyclable. It looks heavy. Does it look easy to use? Not really. The heat is going to heat up that handle. It's also, if you lift that off, you're going to get scalded. This to me looks much better. The fact you've got a polymer handle out here and you can hold the fluid away from you opposed to having the fluid underneath you. It's also of course electric, and it allows you to place that onto a board and take that off of a board very easily. That didn't used to happen with the older kettles. They were hard plugged in. When I say hard plugged, you could take them out, but they were always connected to the wall unless you removed them, a bit more like a hi-fi or something that you get at home. And this red one, it's attractive, but it's very similar to this one, but it looks like a sort of modern edition. So we've got ergonomics. Ergonomics is not about anthropometrics. It's about how you're interacting with the product. So with this one, you're going to get burnt. I would have thought, this is going to heat up and it's going to hurt your hand. Maybe you get 2 hands on it. Maybe that's a good thing. With this one, the ergonomics, you can hold away from your body. It looks like it's got some sort of shaped handle. You can also lift it off of the heating plate, can't you? Carry it around the room. You can use it in most houses. This one is quite similar to that. But of course it's got a bit of insulation. You're not using words really like insulation around the handle, so it's going to get cooler. So let's have a look at the answers on this. So ergonomics, handle, allowing for firm, safe grip, polymer construction is an insulator. Carrying handle is away, opposite side from the steam. Okay, so you're carrying it away from your body. Polymer could make use of thermochromatic pigment, so it could indicate when the contents are hot. Whistling kettle gives an audible sound, which is really good. Remember, ergonomics is your senses, so it's what it smells like, what it tastes like, what it smells like, what it looks like, how it reacts with all the senses. I've forgotten one of the senses there, haven't I? Awkward carrying position with handle over top of main kettle. No viewing window on cast. That makes it easier to use visually. So then we go on to functionality. No trailing flex with the iron stovetop kettles. We've got hinged lids. We've got lids which are accessed via a button. Docking unit means you can go anywhere. Lightweight for elderly people. Bigger handle for elderly people. Thermochromatic strip when the water is boiled. Cast iron kettle can be used on an open fire. So if you want to take it camping, that'd be really good. You can't use the polymer kettle outside, can you, unless you've got an outside supply of electricity. Cast iron kettle is heavy, could be dropped. Risk of electric shock. Rising steam. Difficult to gauge in the other stovetop kettles how much fluid is in there because you can't see. It doesn't have a window. So we've got loads of bits and pieces here, and you can probably see what you got. What we haven't really done, well described and justified analysis. Justified analysis containing full evaluation, drawing on conclusions, having considered both positive and negative factors. Drawing on conclusions. Now that's the mark scheme, and so if you weren't making conclusions, really I was giving you 2 because you were just analysing. So you've got to draw on the conclusions. All right, bit of a learning curve, I think, this. And let's go on to the next question. Primary and secondary research. Primary research, we went through it during the revision lessons, but look, I just maybe think that you haven't really quite covered it in enough detail yet, and we're going to cover it when we do our product analysis in the next few weeks. But primary research is research that you do, and you do it firsthand. For example, if you are making a chair, you may well get a chair, put it in front of you, look how long the legs are, look at what the legs are made of, look at how it's jointed, look at how people sit in it, look at how comfortable the seat is, pick it up and feel how light it is, see if it's easy to move around the room. That's primary research. That's what you're doing. You're interacting with the product. Well, that's all well and good, but if we wanted a wider approach and see the trends out there for because we're trying to make something which was fashionable and appealing to, let's say, I don't know, 19 to 25-year-olds, it would be probably better to go on the internet and have a look at all the different options that are already available. And that's secondary research. So secondary research is the things that we get from the internet, or things that we look at on the internet, chairs, for example, or we might look in newspapers, or we might look in books. So it says, and what's good about that is that we can conduct a lot more research a lot more quickly. However, when we conduct that sort of research, we are not interacting with the product, and so we don't know the weight. We're not experiencing the product. And so both forms of research are good and they have their strengths, but that is the difference. And let's just go and make sure that AQA agree with me. So what have we got? Oh yeah, you've got to name 2 or more named examples. Describe the following 2 types of investigation. Give examples, not example, give examples to show they can help when designing. And so what have we got here? We've got questionnaires, material testing, which I think is in both actually, product analysis, measuring, useful sizes, surveys, focus groups, and the same sort of thing applies for the next. Secondary research involves use of data, use of materials again, use of books, magazines, publish anthropometric and ergonomic data, TV programs. Good. Consumer sources, e.g. Watchdog, that is so old, isn't it? I doubt if you even know what that is, which is quite amusing. Okay. Right. And we are moving to 22, which, to be honest with you, I didn't really look at. I just looked at the answers, and I think everyone got it right. Wasn't it 35 and 85 or something? Everyone got that right. So, and here, just so you're completely clear on this, you've got to put the 85 in there and the 35 in there as a bar graph, if that's the correct bar chart, sorry. And what it is called at the bottom here, or the x-axis represents popularity of votes. Not popularity of votes as a percentage. Okay? So if you wrote percentage, I think it was James did. You got it wrong. It's just popularity of votes along that x-axis, and here it is, popularity of different votes. Okay, there we go. Spec points. There were some bad answers here. I probably awarded marks too readily in this area. With the specification, make a point. It mustn't have sharp edges, right? That's absolutely fine. If you wrote anything like just a tiny statement like sharp edges, heavy, water resistant, colourful, you got nothing. It's the middle ground I wasn't too sure on. It must have curved corners, because I would like to have some sort of justification as to why does it need to have curved corners. And I'm not too sure whether they were asking for that or not, but I use my own discretion really in marking this. And it should always really, you should make a statement in this and then you should justify it in terms of the user. It must have curved corners so that the children who are using the toy don't bash themselves in the face and hurt themselves with a sharp corner. So that's rambling a bit, but you understand I'm justifying it in terms of the user. Okay, it must be colourful so that it is attractive to the clientele, to the children between 3 and 5 who would like to use it. Justify it in terms of the user. So, and you can see indicative content. This doesn't justify it as much as I would like, but that's what I've gone for really for 4 marks. But as I say, I've awarded marks quite liberally. If you're just making statements, must be strong, must not be too big, must be made from cheap materials, you get 0. Okay. So last 2 questions, not long to go now, and we're going down to, I can't really show you this, can I? It certainly was had some mixed responses. Just remember, 2-point perspective has 2 points, and you start by doing that sort of common line in the middle and you project up to it. And we can go and see some of the responses on this. That's from looking from underneath. So if you did something like that, you were going to get a lot of marks. What they were looking for really was a rough 3-dimensional view, and then if you did the overhang here of the roof, or if you put the hook in, that's when you got your 4th point. So you got 3 points for good drawing, and then you got your 4th point for the hook. So I started giving points for hooks. Some of you did oblique, which means it's flat at the front. It's not 2 different angles of perspective. But I think you did okay in that, and I think we could easily get some more marks off of that. Which brings me on to the final question, I believe. Yes, final questions about angles. So 2 different, what they're really looking for here is they are looking for this angle. So what they want to know is that length, and that is of course half of 170, which is 85. So your first mark comes from recognizing that you've got 85 in there. So if you've put 85 in there, or you've put 85 down here, you get 1 mark. And then you've got to use the correct trigonometry, which is, and it's a long time, I think it's tan, isn't it? Is that right? You're looking at opposite, you're not looking at hypotenuse, so you're looking at adjacent opposite. I think it's tan. So I think it's something like opposite divided by adjacent. Is that the right way round, or is it adjacent divided by opposite? And then you've got to, is it inverse tan, I think? We'll give you the angle. So if you got the answer right, I gave you the 4 marks as long as I have got 85 seen. And then what do we got down here? Correct formula of tan, that's all they've put in. I think that's the correct formula. If you don't know, come and see me and I'll sit down and really try and work it out. But yeah, you can see what they've done is they've drawn it here. Okay, so that is it. Hopefully that is that's helped you somewhat, and I know I've gone on for a bit longer than I wanted to, but you can look over your paper and make sure that you've got the marks, or you can probably identify where you've lost marks, and you can work out what you need to work on in the future. And go speak to your teacher about it, because I'm sure they'll help you out, and indeed speak to me about it if you're one of my boys, because I'll be happy to. All right, cheers.